I don't know, I haven't thought about it enough, but you could probably figure it out. 2 more lessons review test. Okay, so this is what? This lesson, 1 more lesson review test. 3 times test. Okay, everybody focusing. So today we're going to be solving trig equations. So we solve trig equations just like we solve other algebraic equations, pretty much. So to solve a trig equation, you'll first isolate the trig function, get it all by itself. So that's like basically isolating the variable. Then second, solve the trig function according to the unit circle if possible. So we want exact answers if possible. If not possible, that's when you will do the inverse to find x or whatever. But only if you cannot find exact answers using the unit circle. So it's just algebra second solve using the unit circle. So a couple things to remember. Sine of x and cosine of x have a period of 2 pi. What does a period mean, everybody? Period means the physical length of one cycle before it repeats, correct? Just a repeat of what's already happened, right, everybody? Going around like this, and then going around again is just a repeat, correct, everybody? So sine and cosine have a period of 2 pi. Around the unit circle once is the length of one full cycle. However, tangent has a period of pi. It repeats after just pi.
Wait, what is
that's a good thing. Oops, let's see. Didn't know I was on the highlight. Good question. So tangent was split evenly like this, right? Over a pi length. So this was negative pi halves and pi halves. And then it looked like that. Yeah. All right. So everybody good? Okay. Awesome. So also I want you to recall the domain and range on sine and cosine and tangent. So recall that domain for sine is all real numbers, correct? Because we can go around the circle as many times as we want, right? That's just creating these sinusoidal waves. Our range, however, bounces between -1 and 1 for sine. Everybody agree? Think about the unit circle, right? Look at the sinusoidal waves. Then the cosine function has a domain of all real numbers. We can keep going around that unit circle. And our range is once again bouncing between -1 and 1. And then looking at tangent, this is what tangent looks like. Our domain is all real numbers except for x cannot be where our asymptotes are. That's when we divide by 0, correct? Everybody, that's not okay. So where the asymptotes are is when we divide by 0. So that's just not in our domain for tangent. But our range for tangent isn't bouncing between -1 and 1. It's growing up to positive infinity and negative infinity. Just a reminder. Okay, so here's my first example. You have your unit circle in front of you. However, on the test, I'm going to be giving you a blank unit circle that you have to fill out. But we'll use a fill-out unit circle today. Okay, everybody? Then we'll be good. Okay, so it says solve. So the first thing we do is follow our algebra steps. Isolate the trig function. Get it all by itself. So notice we have sine of x, so we want to put all of our sine of x's on the same side of the equation. So we're just using algebra. So I'm going to give you a second if you want to write down that example before I start. Okay, so let's add sine x to both sides. I'm going to show all my work here. Add sine of x. So let's combine like terms. Sine of x plus sine of x is how many sine of x's? So we have 2 sine of x's, and then we have plus root 2 equals 0 right now. So we're solving for sine of x. We need to get the trig function alone. So we'll subtract root 2 from both sides. So we have 2 sine of x equals negative root 2, and then we'll divide both sides by 2. So we have the statement sine of x equals negative root 2 over 2. So now look, this is a value on our unit circle, so we're going to solve by just looking at our unit circle here. We're not going to take the inverse because we want exact answers only. So when the sine, remember that xy points, xy, cosine of x is x, and then sine of y is sine of x, sine, right, everybody? So when is our sine value negative root 2 over 2? So sine is y. Let's look at our unit circle. Now sine has a period. This is one thing you have to remember. Sine has a period of 2 pi. So we've got to give all of the solutions on the interval of 2 pi. So there might be more than one solution. Does that make sense? So let's look here. When does it equal negative root 2 over 2? Right there, which is 7 pi fourths and 5 pi fourths right there. So we have two answers. So one of our answers was 7 pi fourths, and one of our answers was 5 pi fourths. Now here's what we have to remember. Because of the wording, it says what are all, we're trying to find all of the solutions. So think about it. If I'm starting here and I go around 360 degrees, won't that put me back in that same spot? And if I go around again and again and again and again, and I can go around however many times, there's going to be infinite solutions here at that place, correct? So we have to say 7 pi fourths plus 2 pi plus 360, and we can do that however many times we want. So 2 pi n. That means n is the number of times you go around. Does that make sense? So it's that answer plus any time we land in that same spot. So plus 2 pi n. Yep. Plus 2 pi n, because that just means anywhere. So you've got to watch, because oftentimes what will happen is they'll say solve this on an interval from 0 to 2 pi, and then you would have only had the answer 7 pi fourths and 5 pi fourths, because that's on the interval from 0 to 2 pi. So if they said from 0 to 4 pi, then you could actually figure out those exact solutions. Does that make sense, everybody? When you just take this and add 2 pi to it, that would be an answer plus 2 pi. Does that make sense, everybody? Because that would be 2 circles, 4 pi. You get what I'm saying? Can you extend your knowledge? Okay, awesome. Next problem, it says solve. So notice, we just follow algebra steps. Get the trig function alone. So we have 3 tangent squared of x minus 1 equals 0. We try to use algebra to solve the easiest way possible. So it's quadratic, but we're able to solve this one pretty easily. Good, so we have 3 tangent squared of x equals positive 1. Then we would divide both sides by 3. Shoop. So we have tangent squared of x equals 1/3. And then we'll, very good, square root both sides of the equation. So we have tangent of x equals, we would rationalize the denominator, because this is really 1 over root 3, which is really root 3 over 3. Very good. Most of you are awesome because you can do it in your head pretty well.
That part was confusing, like how it's 1 and
Yep. Square root of 1 is just 1, and then square root of 3, square root of 3.
So like I could write a square root of 1.
Yep, and then we'd simplify each of those, which would be 1 over root 3, and then we'd rationalize. Okay, I'm glad you asked then. Any questions on that? Okay, now it says when is the tangent square root of 3 over 3? So we've got to look. Remember what tangent is. You have to maybe remind yourself. Tangent, very good, is sine of x over cosine of x, which is really y over x. So which y over x will simplify to be this value? 30 degrees or 60 degrees? Which one? So let's test it. 1/2, so 30 degrees. That would be 1/2 divided by root 3 over 2. So dividing fractions is easy as pie. You flip the second, right? 2 over root 3. Isn't that 1 over root 3, guys? Which is root 3 over 3. So it's 30 degrees. Yes. I knew it was either 30, 60, or 45. 45 is easy though, it's 1, right? Well, because remember, these are all 30, 60, 90 triangles in here, right? So I knew it was one of those. It's a special right triangle. I just remember though, once you see these a few times, you'll remember. Yes. Yes. Yep, unless it specifies otherwise. So, 30 is happened to be it. Everybody good? Yes.
So there wouldn't be another.
Well, we'll have to think about this. So it's pi 6, right? We know that pi 6 is one of our answers, right? So pi 6, is there another place that it's going to simplify? So that tangent is going to simplify to be square root of 3 over 3, positive root 3 over 3. Yeah. Good. Oh, wait, let's see. 7. Yeah, good. 7 pi 6, because isn't a negative divided by a negative a positive? So you're right. At 7 pi 6, so it was here, right? And then it was also here, because a negative divided by a negative, right? Look, if I made this negative and negative, it'll still come out positive. So we also have 7 pi 6 as a solution. Yes, these would both, because we want all the solutions. Oh, actually, no. In this one, we wouldn't have that. Okay, this is a good point to make. So I have both of those. Technically, yes, those are both solutions. However, we don't write 7 pi 6, because what we're going to do is say pi over 6 plus pi n. Now, why is it only plus pi n? Because, do you get why? So this is a solution. We weren't wrong, but we're just saying tangent repeats, tangents period, is pi. So that means we repeat after pi amount. So we're going to have pi 6 as a solution plus pi, however many times we want to add pi. Now notice pi 6 plus pi would put me at 7 pi 6, everybody. So does that make sense? Okay. We're all good? So tangent's the special one. It has plus pi n instead of plus 2 pi n. Okay, good. All right, let's go on to the next problem if no one's confused. Okay. So looking at this one, notice we have cotangent of x, cosine squared of x is equal to 2 cotangent of x. So what we do is isolate the trig function. So what we're going to do is get this, all of it to trig function. So let's get it set equal to 0 then. So we have cotangent x, cosine squared of x. We're going to subtract 2 cotangent of x equals 0. Now from here, we can't really solve, well, we can do something here. We would always try to solve by factoring if possible first. So can anything factor out in common here? Cotangent. So let's go ahead and see if we can factor it. If not, we're going to tackle this differently. However, it does factor, so we'll factor out cotangent of x. So divide by cotangent x, divide by cotangent x. So then left in our parentheses would be cosine squared x minus 2 equals 0. Now think about how solving like a quadratic. If you can factor a quadratic, you can set each of your factors equal to 0 and solve. So now looking at this, we can set each of those equal to 0 and solve. Everybody understand what I'm saying? Because it's now factored. So we can set factors equal to 0 and solve. So we have cotangent of x. When does that equal 0? And we're also looking at cosine squared x minus 2 equals 0. So I factored it. Now we can set our factors equal to 0. So then you have to say to yourself, what does cotangent really mean? Cotangent really means it's the reciprocal of tangent. Tangent is opposite over adjacent, correct? So we're looking for adjacent over opposite, or really we look at it on the unit circle. So instead of thinking of it as a right triangle, let's think of tangent is normally, tangent of x is sine is y over x, correct? So isn't cotangent going to be x divided by y? Okay, so when does our x divided by y equal 0 on our unit circle? Look at it. It's got to be x divided by y. X, y. X, y. So it's got to be x divided by y. So look right here. X divided by y here is undefined, correct? Not that. X divided by y. Okay, what about here? 0 divided by 1 is 0. So that's one of our solutions. Now cotangent, so we would say pi halves is an answer. Now technically, isn't 3 pi halves also a solution? However, that's one of the repeats, because if tangent has a period of pi, so does cotangent. So we would only need to write pi halves plus pi n. So there's a solution. And then now let's solve for this one. So we would isolate the trig function, so we'd add 2. So we have cosine squared of x equals 2. Now won't we square root both sides? So we have cosine of x equals plus and minus, because when we take the square root of both sides of an equation, we can't forget plus or minus. Plus or minus root 2. Now the question for you is that a value on our unit circle? No, so this is when it's appropriate to then use the inverse to solve for x instead of using just our unit circle. Does that make sense? Yeah, because now we're trying to solve for x. So when we inverse cosine both sides, guys? So let's cosine inverse both sides of the equation. So we would have x is equal to cosine inverse of plus or minus root 2. So, is that a possibility? Try typing it into your calculator. Because when we take a square root of both sides of an equation, we can't forget plus or minus. Oh, we'll just treat them as separate answers. So we'll be looking at cosine inverse of root 2, and we'll be looking at cosine inverse of negative root 2. Type it in. What do you get? Error. Right? Because that is larger than 1. And then remember back to cosine inverse. Wasn't our available inputs between 0 and 1, everybody, for cosine inverse? So because we got error, we know that this is like not a solution. Does that make sense, everybody? So we throw those solutions out. So our only solution is this. It's kind of like an extraneous solution. Does that make sense? Cool. All right, next problem. I'll let you write it down. I want you to notice something different. In the instructions here, it says solve 2 sine squared x minus sine of x minus 1 is equal to 0, only on an interval from 0 to 2 pi. So we're going to have just the solutions on that one interval. So we won't have to write plus 2 pi in here. So now looking at this, we would isolate the trig function, but it looks like, I mean, the thing is with this one, it's quadratic. Correct, everybody? Sine squared x minus sine x. It's quadratic in form. So notice we can't factor out a sine x to make it linear, right? Because this doesn't have a sign. This term doesn't have a sign. So you'd say to yourself, it's set equal to 0. That's my first step, and now I'm going to factor it. That's how we solve if we, solve by factoring. So we're going to make a u substitution. I'm going to say, let u equal sine of x, so that I can think of this as an easier term. So that would be 2u squared minus u minus 1 equals 0. Now let's factor that. We'll multiply to be negative 2, adds it to be negative 1. 1 times 2, it'll be negative 2. You would not make the tragic mistake of quick factoring something you couldn't, so you would drop and break. So we drop down 2u squared, we drop down negative 1, we break down our middle term. I'm going to put it as negative 2u plus 1u. Then we're grouping. So pulling out a 2u, left is u minus 1, pulling out negative 1, divide by negative 1. So that would be u. Did I mess up somewhere?
Yeah, you didn't pull out.
Oh, we shouldn't be pulling out negative. I thought that was a negative. That's a plus sign. Sorry. We're not pulling out negative 1. We're going to pull out positive 1. So left is u minus 1. Correct?
Yeah.
Now the safe haven's the same, so it did factor, so we can factor that out. U minus 1. So it divided out, leaving me with 2u plus 1. Now u is not u, it's actually sine of x, so let's write this appropriately. Sine of x minus 1 times 2 sine of x plus 1. Now we factored it. The whole point of factoring is so that we can set our factors equal to 0 and solve at this point. So we would say, okay, sine of x minus 1 equals 0, and 2 sine of x plus 1 equals 0. Solve for sine. So we'd add 1. When does our sine of x equal 1? That is a value on my unit circle, so I will not be using inverse. I'll be using my knowledge. Sine is y, so where's the only place? Pi halves. Very good. That's our only solution for that piece, because we don't need to do plus 2 pi n, because it just said on an interval from 0 to 2 pi. So there's one of our solutions. And then let's keep solving here. So we'd subtract 1, divide by 2. So when does our sine equal negative 1/2? Okay, so it's got to be negative 1/2, so you were on the right track. Negative 1/2. And it's y, right? 11 pi 6 is one of them. Very good. 11 pi 6 is one of them. And then anywhere else? Oh, right there. And 7 pi 6. And there's our other solutions. Well, if you just think about how the unit circle works, there's going to be 2 places where it equals negative 1/2, right? Because they're x, y points that are the same, just with different signs. Good question. So we have 3 in here. Okay, awesome. Let's go on to the next example. Doing good. We're almost done, guys, and then you're going to have time to work in class. Stay with me. Stay with me, though. Here you go. So we have secant squared x minus 3, secant x minus 2 equals 0. Notice, once again, this one is quadratic in form. So we're going to do another u substitution. Let u equal secant x So that would be u squared minus 3u minus 2 equals 0. We're going to try solving by factoring. Well, it multiplies to be negative 2 and adds up to be negative 3, 1 times 2, but both of those would have to be negative. So does that work? Not quite, because that doesn't multiply to be negative 2. So this is not factorable. So that means we would have to solve this one with quadratic formula. So we would say u is equal to plus or minus, nope, u is equal to x equals negative b, so u equals negative b, so opposite of b, which would be 3, plus or minus the square root of b squared. You guys actually thought that I was an opera singer? B squared minus 4ac all over 2a. Okay, awesome. So we have u is equal to 3 plus or minus the square root of 9 plus 8, which is 17, all over 2. Correcto. So now we have simplified this completely. 17 doesn't break down. So let's replace u with what it should be at secant. So we're saying when does secant of x equal 3 plus or minus the square root of 17 over 2? Is that on our unit circle? No. So you take the secant inverse of both sides of the equation, right? To get x alone? Yep, so 1 over inverse cosine. Very good. So we would have x is equal to 1 over cosine inverse of all that stuff. Let's see if it's a possibility. You treat them differently, by the way. So we would also have this. 1 over cosine inverse of 3 minus root 17 over 2. And in this one, decimal answers would be acceptable because it's not on the unit circle. Did this one work? The negative one did work? Okay, awesome. So this would be our answer, but this one was extraneous?
Yeah.
Cool. That's good enough. You could. Yeah, you could. Which, does anyone want to shout out what they got for that? 0.0. Perfect. That would be an acceptable answer because you can't find it on the unit circle. Cool. Okay, sweet. Moving on. A couple more examples. Doing good. Really good here. So we have sine squared x plus 3 cosine of x minus 3. So the problem is, notice here, so if we're noticing like how to tackle solving this. Notice we can't factor anything out. That's our first choice. Notice we can't just isolate sine or cosine because then we're still dealing with sine or cosine. Notice though, the problem is we also, it kind of looks quadratic in form, but notice we have sine and cosines which are different. So do you see how we can't do a u substitution? Yeah. So that means we're going to have to use our trig identities to change this into something that we can solve. Let's write something that's equal but different in form. So equal but different in form. That's what trig identities do. They allow us to change it but have it equal. So here's what, the only thing I can change, cosine's nothing with sine, right? But isn't sine squared changeable into cosine? Yes. Isn't sine squared x plus cosine squared x equal to 1? So isn't sine squared x 1 minus cosine squared x? Guys? So let's replace that with that. So we have 2 times all of sine squared x, which we're replacing with that. So 2 times 1 minus cosine squared x plus 3 cosine of x minus 3 equals 0. So now we have it all in terms of at least cosine, which is what we want. So let's distribute the 2 through. Ding, ding. So we have 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. Let's solve. Let's combine like terms, I mean. So negative 2 cosine squared of x, right? Plus 3 cosine of x, and then we'll combine 2 minus 3, which is negative 1 equals 0. So now we put it into a quadratic informed problem, because now we can do a u substitution. So we would have, let u equal cosine of x, so that means that we have negative 2u squared plus 3u minus 1 equals 0. Let's solve this one by factoring. What multiplies, actually, I'm going to, okay, what? Well, multiplies to be negative 2 times negative 1, which is positive 2, and add them to be 3. 1 times 2, you said. Yep, that's right. So we drop and break, because it's long factoring, negative 2u squared plus 2u plus 1u minus 1 equals 0. Factor by grouping, ding, ding. So we'd pull out a negative, wouldn't we?
Yeah.
Negative 2u, so left is u minus 1. We factor out a positive 1. So then left was u minus 1. So we'll factor out u minus 1. And left is negative 2u plus 1. Now instead of u, let's put in our cosine. So we have cosine of x minus 1 times negative 2 cosine of x plus 1 equals 0. And now that we've factored it, we can set each of those equal to 0. And solve. So let's do that. Cosine of x minus 1 equals 0. Negative 2 cosine of x plus 1 equals 0. So we are saying, when does cosine of x equal 1 on the unit circle? And cosine has an interval from 0 to 2 pi, right? So there's 2 places. Cosine's 1, guys. X. So 0 and pi. True. No, wait. It's not 2 pi. I mean, it's not pi. Okay, so it's 0, but then 2 pi is a repeat of 0. Does that make sense? Yep, so 0 plus 2 pi n, which is just 2 pi n, right? There's one of our answers. And then over here, we'll subtract 1, divide by negative 2. So we're looking at cosine of x is equal to 1/2. There's 2 places on our unit circle. Cosine is x. Pi thirds. Anyone else?
And,
Yep.
so with pi thirds plus
It's not 5 pi thirds though. Because it's positive 1/2. So doesn't it? Oh yeah, it is 5 pi thirds. Sorry. My fault. 100% there. I can't.
Whoa.
And 5 pi thirds. And then plus 2 pi n. Plus 2 pi n. Because it wasn't only over that interval. Good. Questions?
Wait, so those are
Yes. Yes.
I think that's
It do you mean like, it depends on the problem. So with this one, it didn't say only find the answers on this interval. Does that make sense? This one said find all the solutions.
So,
Yeah. So then you would have 2 pi n, and you had 2 pi, not n, and 4 pi, right? Because you added 2 pi to that, right? No, you would have had, if it was over an interval, yeah, it would be 2 pi and 4 pi, like you said. Does that make sense? I shouldn't have crossed those out. And then you would have pi thirds plus 2 pi, right? And then you'd have 5 thirds plus 2 pi, but then you'd simplify it. Does that make sense, everybody? Okay, good questions. Really good questions. Okay, we're almost there. So it says, solve. So looking at this one, guys, notice there's nothing we can do here. Like, we can't do anything. We can't change anything. There's nothing squared. We're stuck. Does everybody see how we're stuck? Because we can't factor it. Everybody understanding? We're almost done, so just stay with me. I can tell by your faces that you're all dying. So we're getting there. Okay, so the only way we could solve this one is by manipulating the equation for our advantage. So maybe we should square both sides. Because if we have cosine squared or sine squared, can't we change it in terms of the other? Yeah. Because just like if you were solving any other type of equation, as long as you do it to both sides of the equations, it's all good. So we're going to square both sides of the equation. Now we wouldn't break the forbidden rule because that would be a tragedy. We know this is cosine of x plus 1 times cosine of x plus 1 equals sine squared x. Let's distribute this out. Cosine squared x plus cosine of x plus cosine of x plus 1 equals sine squared x. Combine like terms. Cosine squared x plus 2 cosine of x plus 1 equals sine squared x. So, should we change things in terms of sine or cosine? Cosine, because look, we have this cosine we wouldn't be able to change. No, we need to get, because we have a cosine and cosine squared, like we're going to have to solve in terms of cosine. So let's change this in terms of cosine, which, what does that equal to? Yep, so we have this, cosine squared x plus 2 cosine of x plus 1 equals 1 minus cosine squared x. And now look, our equation is all in terms of cosine. So now we can solve. So we would add cosine squared to both sides. So we have 2 cosine squared of x. Let's subtract 1, subtract 1. So then plus 2 cosines of x, and those happen to be 0, equals 0. So now we can solve by factoring. Whole lot of? Yeah, 2 cosine x. I like it. So we'll factor out 2 cosine of x, and then left would be cosine of x plus 1. Now look, we set each of our factors equal to 0 and solve. So 2 cosine of x equals 0, divide by 2. So when does our cosine equal 0? Yep. Oh yeah, you're right. It's not, yeah, you're right. It's at pi halves, right? At pi halves and at 3 pi halves. And it just said over an interval from 0 to 2 pi, so we don't need to add 2 pi in. Then we'll do this one. When does the cosine of x equal -1? Because I set it equal to 0, then I subtracted 1. Pi. Now guys, didn't we take an equation and manipulate both sides of it? We changed it, right? That can introduce extraneous solutions, so we need to check those solutions. We would check our solutions. One of them is extraneous, so we check them back in the original. So we would look and say, so I'm going to write down the original. Cosine of x plus 1 equals sine of x. So let's check. Here we go. We're checking, how do we check solutions? We plug them back into the original problem. So here's my original. Let's check pi halves. So cosine of pi halves plus 1 needs to be equal to sine of pi halves. Let's see what that is. What's the cosine of pi halves, everybody? 0 plus 1, what's the sine of pi halves? 1. So is that a true statement? Yeah, so it's not extraneous. That one gets to stay. Let's check this one. Cosine of 3 pi halves plus 1. Does that equal the sine of 3 pi halves? Let's check it. So what's cosine of 3 pi halves? 0 plus 1 equals the sine of 3 pi halves, which is 1 equal to -1. Extraneous solution, so we just cross it out. And then pi. So we're checking pi now. Cosine of pi plus 1, does that equal the sine of pi? Cosine of pi is -1 plus 1 equals sine of pi is 0. 0 equals 0 is a true statement, so that's not extraneous.
Can you leave that there?
Yeah, of course.
We're different.
So it says solve. 2 cosine of 3t minus 1 equals 0. Now, look, the only difference is there's a 3 in front of the t. Pretend the 3 is not there, solve it like normal, and then we'll consider the 3. So, let's pretend the 3 is not there. We're just going to solve it like normal. So we would isolate, if possible, solve for cosine. So this one's easy, right? We'll just add 1, divide by 2. So we have cosine of 3t equals 1/2, correct? So what you're going to do is answer the question, when does cosine equal 1/2? Well, let's look. Where does it equal 1/2? Cosine's x right there, correct? And right there. So we have pi thirds, and it didn't say on a certain interval. So pi thirds plus 2 pi n, because cosine's period's 2 pi, and we also have 5 pi thirds plus 2 pi n. No. Yes. Now, this is what we have. We actually have this. 3t equals pi thirds plus 2 pi n, and 3t equals 5 pi thirds plus 2 pi n. So instead of just having a t, we have a 3 in front of t. So now it's just algebra to solve for t. So why don't we divide by 3, or, right, to get t alone? Or easier said, let's just multiply both sides by 1/3. 1/3. You gotta multiply that even by 1/3. So times by a third, times by a third, times by a third. So now t is alone. Now t is alone. So we're gonna have t is equal to up here pi 6. Because look, pi times 1 is pi. 3 times 3 is 9. So I meant pi 9. And then plus 2 pi thirds n, correct? Because I just put the 2 pi to make it convenient right there. Everybody see what I did? And then our other answer would be t is equal to 5 pi ninths. We multiply straight across. Plus 2 pi thirds n. Nope, it's the exact same thing. You just have one extra step. So one more. Now, here's why we didn't have an extraneous solution in this one. We didn't have to change anything. We just solved. So let's do this one. So we would subtract 3, divide by 3. So that's tangent of x over 2 equals -1, because we subtract 3, divide by 3. Solve it like just regular old tangent. So remember, tangent's period is from 0 to pi. And -1 is y over x, correct? So won't that be this? Right here? That one? So 3 pi fourths is our answer. So 3 pi fourths plus just pi n though. And now we have x over 2 is equal to 3 pi fourths plus pi n. So we multiply both sides by 2 times 2 times 2. So then x is alone. So x is equal to 6 pi fourths plus 2 pi n, which simplifies to be x is equal to 3 pi halves plus 2 pi n. So not any harder, just one extra step. And that is almost it. Last one, this is literally the last one. Okay, secant squared x minus 2 tangent x equals 4. So this is one where we can't factor out anything. We can't simply solve. We can't substitute. So we've got to change something. So let's change it in terms of tangent. Why did I choose tangent? Because we can't change tangent. Tangent's tangent. There's not a squared on it. What's this trig identity? Is it 1 plus tangent squared? So we have 1 plus tangent squared instead of that, minus 2 tangent of x, and then let's equals 4. So let's get everything equal to 0 so we can factor it. So we have tangent squared x, because we'll combine like terms, minus 2 tangent x, we're putting it in standard form, which means highest degree to lowest degree, 1, and then we'd subtract 4. Minus 3 equals 0, so now we can factor it. Let u equal tangent of x, so we have u squared minus 2u minus 3 equals 0. What multiplies to be -3 adds up to be -2. 1 times 3, -3. It is possible. So we have u plus 1 times u minus 3 equals 0. Solving by factoring, right? So tangent of x plus 1 equals 0. I'm just jumping steps here. And tangent of x plus 3 equals 0. Let's solve for x in each case. Good point. Minus 3. So we subtract 1. When does tangent of x equal -1? Same as last time. Wasn't that 3 pi fourths? 3 pi fourths. And then on an interval, oh no, this is all of them. So plus, I guess, 2 pi. I think this one should have said on an interval from, I don't know. Anyways, just pi, right? Plus pi. Good catch, Rebecca. Then, over here, let's solve. So we would add 3. So tangent of x equals 3. Is that on my unit circle, anyone? You're thinking maybe yes, because it does kind of simplify to be close to. We do have root 3. Does that make sense? So we would say no. So this would be the appropriate time to use inverses. So we would inverse both sides. So x is equal to tangent inverse of 3. Or it might say x is equal to arc tangent, because that is what inverse tangent means, of 3. Cool. So that would be our answer. And then you got 70.5. So that would be giving it in degrees, right? Probably. Yeah. Yes. I see what you're saying. No. All right. That's That's it. Well, that's so attractive. I wish I could do that.